Hello everyone, I'm Xiao Gang. I've already started this code calculation. Let me show you, it's actually a box, right? And here our layout is similar to before, but its design might be a bit more complex. So let's not have it search our engine source code. Let's find the programs, then find our own lxsha programs, and put it in the proite directory. You can see it's divided into several stages, right? In the end, our code line count should be 1748. We really want it in the first stage. It's traversing how many there are here. Picked this directory. And the second stage is traversing all files, and the last stage is processing each file one by one. How many lines of code it has, then accumulating the code line count. I think this is a stage tick-based word. And we also calculated the time. That is, our total time should be innovation seconds, and when we were in the folder. It took 0.01 seconds, then traversing all files. It took 0.04 seconds to save the files. Then when reading the files, it took 0.1 seconds. Briefly explain these several parts of content. The first part is equivalent to first find all the folders. Then the second part is to find all the files inside all the folders. The third part is to read all the files and read the code functions inside them one by one. And we did not use multi-threading. We are taking the minute hand. We split a very large task into individual ticks, and each tick refers to processing one or several such files. In such a scenario, then you can add multi-threading and such to optimize it. So based on this approach, you can do something like brute forcing, where you write down all the key information, then you call the decompression interface. It will tell you whether decompression succeeded or failed. Then you divide all the permutations of keys into many subtasks, into many threads, and test them concurrently at the same time. This way, all CPUs are fully utilized, then decompress like this. This will make the decompression efficiency much higher. So this is a fairly important concept. Okay, so let's put this here. Then we'll start writing this code together with everyone. Obviously, we'll still write our layout first, because this time we'll put all the code in this. Inside this, put it inside this. So our layout needs to be much clearer. Then we have a counter box on this side. As for this layout, it's still written the same way. First, we declare a struct here. This struct is nth counter code. This is the struct we use to define specific tasks. It should be called this name now. This name. Then we declare our calculation class. Okay, we haven't written it out yet. But no rush. We'll put the class name here. Okay, it's called this name. Then I'll just paste it over later. Okay, this is a bit convoluted. Okay, so this is actually our slate, this canvas panel area. Then we put this over here. Okay, so let's not write anything for now. And this is the actual scenario where we call this interface to execute. Then here, we will write out our counter code. For this counter code, we will have it inherit from this counter code. Yes. Then let's remember to paste the name here as well. This name. We will have it inherit from this picker, because only then can it tick. Then let's give it a 7 level, T2 from this. This way it can be converted into a weak pointer, that is, a weak smart pointer. Okay, as for the content here, we might need to temporarily place this tick here. Okay, this is our tick, but we haven't written anything yet. The content here is quite complex. We'll write it in the next few steps. Let's first see if it compiles successfully. Let's check if we need to write this constructor. This place, there is a warning here, but it compiled successfully. That is to say, here, we'd better include this constructor as well. Let's include this virtual constructor. Okay. Let's write the constructor too. because this needs to be used in our Slater. The function constructed like this, then why do we need to pass these two parameters? These two parameters actually correspond to these two positions, correspond to this position and this scroll box. Yes, we need to pass these two self pointers in, because it makes it easier for us to modify. So this is where these two constructors are used. Their instantiation is in our this Slate count box where it is instantiated. Then we release it here. We won't write anything for now, because it's quite complicated here. Okay, then let's modify this code here, because obviously we made a mistake here. The file name is wrong. This should be count. If we change the file name, then when including it here, the include statement might also need to be changed if we change it here. Let's think again. This code part might need to be changed here. No need to change here. We only made a mistake here. Then let's go back here. We haven't written any functionality yet. That's normal. Let's compile it. Obviously, this name needs to be changed again. Let's add B to counter and compile again. Now that we've written it this way, this time we'll write an enum, and we'll define this enum to specify which state it is in. First, the first state is the idle state. That is the idle state. Then this is phase 1, which is to traverse the folder. Phase 2 is to traverse the files. Phase 3 is to complete the reading of each file. It needs to read the content inside the file. The first stage is complete, and this max is just a reserved segment. Okay, whether we write this here or not, whether it supports this reflection or not, it probably doesn't matter much. Because this doesn't seem to affect anything, we can use this, but it cannot be reflected to Blueprint, because for a standalone program, there is no such thing as reflecting to Blueprint. Okay. So let's go back to our layout here. Everything here is empty. We'll write this in the next lesson or the one after. Go back to our color box, then go back to our constructor here. Okay, back to the construction part. Still our usual routine. First, we need to find the objects we want to use. First, we still need to find the road position we used last time. You can see that what we use here, we first include the header file. This header file should be on YouTube. We can click into it. If it doesn't allow clicking here, then we do it here. We use the CountCode header file. We did not use modify them because we don't want them to interfere with each other. Then here, we still create our first file directory. The names are all the same. Actually, this is it. We create this direct light. Then we create a log here. This log is actually a scrolling tide. This is a scrolling tide. You can see this is a scrolling tide. The way to create it is actually the same. Look, we left a scrolling tide, and because it's diploid programming, so we add another tide. Inside the tide is actually a text box. So now we have two of these. And at this point, after having these two things, let's look here. Actually, these two things correspond to what we need to change. It's because we often modify something like this. We frequently make changes to it. Okay, then through our makeShare method, good, we find our object. Okay, that's it. We let it create an instance of this object. Then we hold it on this Slate. So its life cycle is tied to the Slate. And because we need it to tick, so we need to have this content code added to management. So we need to write a method here. We call this method add to manage because after you instantiate, it definitely has an initialization process. It currently doesn't have this method. Let's write this method. Okay, let's call this method here. This is a public one. It needs to be called at the instantiation point. Actually, we could write this method inside the constructor, but we've explicitly written it out here. We can move this method entirely into the constructor. That way, the user won't even notice it. right? Then here we get our call. We get this call as it. So we need to include the header file. We need to include the header file. Okay, then after obtaining this image file, we can get this object. Then we directly call this object and ID give it. Then at this point, we make it to this in shared. This way we get a v pointer to it. That's it. Okay, then after we pass this object over, our tick will be called here. At this location, you can see that as long as it hasn't been removed, it will be called here. Then we go back to our slate. This content box, okay. This place says that this pointer points to CountCom, which is not allowed. Then let's check if it's ours. Why is the pointer not allowed here? Let's check it. This is because we didn't include the header file, because you are calling a method inside it. So you need to include this header file. That should do it. And here, we need to add a prefix. Yeah, okay. Good, that should work now. Because you are calling a method, that's why it can know what exactly you are calling. Okay, at this point, we need to set up some search rules. Actually, the idea behind these search rules is still the same. We will add an input content. This input content, it is first of all our input box. So it's this input box. We can add some search rules here. By default, our most default ones are H and CPC, right? Okay. So after adding the H rule, then we need to create this button. And this button is for how to add the donate rule. Let's check if we have this dot now. Let's click one. Key. Let's take a look at clicking CS to see if it works. This part hasn't been done. It probably hasn't been implemented. Then let's just leave it alone. We'll keep it as is. Everyone can do it themselves. This function hasn't been implemented because in this battle, you'll notice it hasn't bound our lambda. It doesn't have this function written. It probably hasn't been developed. Okay, next we need to turn this box into a scroll slot as well. And here we declared a scroll slot. This scroll slot, that's actually our prefix. By default, we only omit the Vinny TH and CPP. This is a bit complicated. We don't have a linkage, so it's hard-coded for now. Then at this point, let's add an ignore button. This is just a reserved segment, that is ignore this button. Then what do we ignore? Let's write it down anyway. You can see what it ignores. It's these items, right? Things like build and so on. Then we can just paste it directly here, because this part hasn't been written yet. So these things are being ignored here. If it involves this build and intermediate, and here it just wrote, just randomly drew a few boxes here. So this feature hasn't been implemented. Okay, let's add a note for everyone. We'll back up this part of the code. Unfinished feature. And don't write it like this. If you write it like this, you put this inside here. It will pass through the scope. It will be gone. So you can't write it like this. Okay. This is an unfinished feature. We give this one. Then you can actually put some images here. There's absolutely no problem with that. Okay, so next, after we have our list, we need to put them together. Putting them together is relatively simple. Let me guide you step by step. It's still the same. Let's format it first. We get our chassis. Then, when we are chassising, start putting things inside. Note that this is a medium width line. Okay, so it's very simple. The first thing we plug in is we need to plug in a number box. The outermost number box. So this number box, we call it voucher box. Here we need a line break. Because this is one line of code, actually, because all of these, he has overloaded all these symbols. That is for the sake of elegance. So we add it like this, the first number box. So that is, should put it a bit further forward. Look at it this way. Okay, so it's this way. This is the first number box. Similarly, we also have a second number box. Right, and then here. The first number box, it only has 2 elements, but it needs a horizontal box. So here, we start by giving it a horizontal box. So we need to put a bracket here. The square bracket. Okay, so here we have a horizontal box. Obviously, this horizontal box has 2 elements. So these 2 elements are respectively these elements. Give this width here an 80% proportion. Okay, put it here. It seems the proportion didn't take effect. Never mind. Okay. As for the proportion here, this horizontal box here hasn't been given a proportion. Okay. We won't give it a proportion. This is the previous one. Okay, so there are only 2 slots. Now we start putting things into this slot. So for the first slot, what are we going to put in? We put our search button in. So here we drag a button. That is the search project button. Then we set its text to search UE5 project code. And for its alignment, we set it to center alignment, both horizontally and vertically. Then when we bind this function, we use a smart pointer to bind it. Then we activate this feature. That is, we activate it here. Obviously, we don't have this function yet, right? What we bind is an object of a smart pointer. So we need to declare this function. We haven't written the functionality yet, but let's declare the function first. Let's write it here. Counter code. It needs, when he clicks, we consider that he can then calculate this. Calculate this code, and its signature is the same as our previous signature. Then here we need to give a handle. Just give a handle to Monto. Let's go back to our slate. Let's learn. So this first button is basically done. Then next, let's write this thing next to it. Next to it is actually our path. So for this path, we make it centered. Numerically, it is centered, but it is left aligned. Okay, and here we have a box. We put this object we declared earlier, fail, here, called fail direct. We put it here. Okay, now we can start and take a look. Let's start and take a look first. Okay, and we find that at this point there is nothing. Having nothing is very normal because here we haven't put this thing in yet. Actually, this writing method is the same. It's just that the way we write it here is, it's like this. You see? Okay, and this place is no longer modifilum. It uses Slate, this Slate. Okay, alright. Now we can start it again. Okay. You can see it appears. Clicking this currently has no effect, of course, and as for this path, it seems to have given up. This path seems to be a shared path we used for testing last time. It's the test insider attachment. So this path is used here. Okay, no problem. So let's go back to our slate. Let's write the slot below. So this place, it is the second number slot. That is this part below. Obviously, it is split into left and right. So here we, if we put it here, let's see if it fits in this position. It should be fine. It should be better to put it here. Then let's add a horizontal box here. So this horizontal box has 2 elements. Because you can see this 20%, this 80%. So here we will add 2 slots. One needs 20%. One is 80%, so let's write 20% first. This M40% is actually just many such cases, so I really want to make it 20%. It is a number box. This one. It is a number box. So let's create a number box. After creating this number box, it has many numerical elements. I just pasted them here. So these several elements are actually the ones we declared earlier. These several elements, right? Look at this first box. It's this one. This box. And then this add row. Ignore row, add row. And because nothing is written here, actually this whole, you can just ignore it. It's an unfinished feature. Okay, now let's write the one on the right. This one here is more important because it is our log, right? So our log, it is obviously a filter box. You see, because there is a text box on the top telling us it is a log. Below that is a scroll box. So here we first leave a number box. First use a number box. Then obviously we need two. One above and one below. So obviously for the one above, we set its height ratio to 0.1%. Then set it to be centered both horizontally and vertically. Then for the elements inside, we just put in our cloth, just a log. You see, put it here. Okay, then for the one below, we give it a height ratio of 90%. Then we just need to take the lockbox we declared earlier, the lockbox we explained at the very beginning, and put it here. At this point, the entire panel layout is done for you. So this is a standard panel layout. Yes, okay, can you see it? This is exactly the same as our layout. You can see that, right? There's no functionality yet. Now we'll add this functionality. Since we're on this topic, let's think about its life cycle. Its life cycle is actually like this. Because this object is here too, we create it here. So this spawn box will be held by this. The Gobble table manager holds it layer by layer. Then this counter box, it will hold this instance. And this instance is where the actual computation happens. Once this is closed, this interface is released. After this slate is released, then this instance will also be released accordingly. Yes, that's roughly the situation. So pay attention to this life cycle management. And at the same time, this instance will also hold references to these pointers and such inside it. Yes, and these pointers are actually held by the slate. You can see, because these are just innate data, they are free-floating. They are held by our xload layering them on layer by layer, right? Okay. So let's compile again. Okay, that's all for this lesson.